Okay, so welcome also from my side to this to this webinar, and many thanks to the Proceedings of the IEEE for making this possible. I mean, for organizing this, and all the staff members who really helped us a lot for the organization. So I will briefly introduce the special issue. So we are talking about special issue on reconfigurable intelligent surfaces, which was published in the Proceedings in September last month. And this special issue contains several papers across multiple disciplines: wireless communications, signal processing, optimization, antennas, metamaterials, of course. And today, I mean, we have a few colleagues who contributed to this special issue, and they will briefly present the main content, I mean, of their papers. And we tried to have people who can represent these different disciplines. So from metamaterials, antenna design, signal processing, and communications. So we also have a nice, I mean, introduction from a colleague, from Marius Poulakis from Huawei, who broadly discussed the role of metamaterials for 6G. So you can have actually a look at the document. So my main task for this short presentation of very few minutes is to introduce the concept to those of you who might be interested, intrigued by this technology, but are not working on it, are not familiar with it. So so we're talking about metasurfaces, which are broadly defined in this this way. So they are structures that are inherently bidimensional. So there are two dimensions that are much larger than the thickness in this case. On top of a substrate, we usually have some tiny antenna elements and some electronic circuits. So thanks to these electronic circuits, we can change the response of these devices to the electromagnetic wave. And then, I mean, we have somehow an interface with the network, which allows us to control this structure, to send the commands, and to then set the electronic circuits. So in wireless communications, they are receiving interest for many reasons. We can classify them in three main categories, at least to the best of my understanding. We have relay type surfaces, which are actually called reconfigurable intelligent surfaces, and their objective is to shape the electromagnetic waves in the environments. Basically, we have these surfaces distributed throughout the environment, and they can modify the response to the electromagnetic waves. Their main characteristic is to be nearly passive, which means that differently from antennas, active antennas, we have no RF chains, no power amplifiers, no baseband processing. So they are utilized for a few main applications. One is to control the multipath. So when you receive many copies of the same message, because of the interactions with the environment, they not always, I mean, reach the destination in phase. So through this technology, you can manipulate the waves in a way that they can reach the destination, the intended destination in phase, and therefore you can get a good signal. You can reach sites, areas that are difficult to reach, so the so-called coverage holes in urban environments, for example, or if your user is behind a wall. And the main point is that while any wall can reflect signals, not all these signals reflected can be useful to you, can be interference, or can just be wasted, I mean, in the environment. You can now tune these reflections in a way that can be useful to you. Okay. And the third one is, even though, I mean, you may have a good line of sight, you can exploit this far scatterer, this wall in this case, in order to get another signal which enhances the rank of the channel, provided that this scatterer is sufficiently far, or some conditions are met in order to get a rank 2 channels, in all those cases where the environment is rank deficient. So these are the main applications for surfaces called RIS. Now, in 1 minute, I just want to tell you that these metasurfaces have much broader applications, and indeed we have colleagues today who build these surfaces and are actually working not only on reflecting surfaces or refracting surfaces, but actually doing much more than that. And some possibilities to use these surfaces as transmitters or receivers, so as very large size antennas. And for example, you may have a very large size base stations, and then you may have a tablet where you attach this metamaterial surface, and it allows you to communicate. In this case, these surfaces are active, so the design constraints change. We have amplifiers, DSP, and etc. They are getting popular in our community because of applications to high frequency bands, so terahertz communications, sub-terahertz communications. If you are at very high frequencies and you have two large surfaces communicating with each other, in general, at not very large distances, the electromagnetic waves are not anymore planar waves, but they are spherical waves. And if this happens, even though the channel is not rich in terms of scattering, you have not many reflections, you can still enable the transmission of multiple streams. So you can enable spatial multiplexing in line of sight MIMO, and people are investigating the fundamental limits of this, implementing the surfaces that do that, and developing the signal processing algorithms and the waveforms to make this work. The beauty of this application is that you can realize a transceiver with a complexity that depends on the number of streams that you can transmit, and then the rest is done in the analog domain, so at the electromagnetic level. And this simplifies a lot the complexity of your transceiver in terms of RF chains, while exploiting the degrees of freedom of this channel. This is another application. A third application is called information metasurfaces. Very quickly, they are utilized, for example, for backscattering communications. This is also called symbiotic radio. And the idea is that in addition to reflecting the signals and utilizing the reflections for communications, you may somehow encode the data into the reflection. For example, by changing the shape of the wave that is transmitted. And there are devices that are able to manipulate the shapes of the waves. Implementing mathematical operations through metasurfaces. Another application is to realize transmitters or MIMO transmitters, encoding data. For example, if you have a surface with many elements, you may be able to encode data onto the activation pattern of these elements. And if you activate this pattern, you can transmit a symbol S1, or otherwise you can transmit this symbol S2. And you can also realize MIMO, so transmitting multiple streams with the same approach, but only having one feeder, one chain that illuminates basically this surface. So once again at lower complexity. Last two slides, and I stop this introduction, is this technology is under discussion within standardization bodies. Among the three, so far there are discussions only pertaining to reconfigurable intelligent surfaces, which is the main topic of the special issue. There are two bodies, standardization bodies. One is the ETSI, the European Telecommunication Standard Institute. There is a group that was established in September last year, so people have been working for 1 year. And the idea is to coordinate the activities around this topic towards the standardization. Within the 3GPP, there are activities around several options in order to provide coverage in future at a reasonable cost in future wireless networks. And one of them is reconfigurable intelligent surfaces. As of today, there is no study item on RIS. It has been under discussion. At the moment, the study item was established for a technology called smart repeaters or network controlled repeaters, which is similar to the RIS in terms of control signaling, but it's still active in the sense that it's a sort of amplifying forward relays with more intelligence. So fundamentally, people are considering then to discuss RIS, or at least, they are trying also to include RIS in the upcoming discussions and hopefully releases of this 3GPP. So I guess that this is everything for this short introduction, and then I will give the floor to my colleagues.